All right, so in the next part of this section, we're gonna go over some of the tools and techniques that are really gonna allow you to solve some involved and like some of the like real statistical and probability problems in this course. So it's kind of I like to think of it as like the meat and potatoes of of this chapter, and almost like in a sense well the probability concepts in the course. So it could be a little complicated, but again, with the proper practice and with using the proper and correct notation, it's going to be pretty. You're going to master anything. It's going to be pretty simple. Again, once you get that fluency down. So we're first going to look at what happens when we add random variables up, and then we're going to look at standard deviation, their differences and stuff like that. So let's say we have two random variables, x and y, where t is going to be equal to their sum. So t equals x plus y. Then the expected value of t, or the mean of t, is going to be equal to the mean of x plus the mean of y. In general, the mean of the sum of several random variables is the sum of their mean. So if you had like t equals x plus y plus z, then the mean of t will be the mean of x plus the mean of y plus the mean of z, and so on and so forth. Now, in this course, when you're dealing with probability problems involving random variables, you're going to need to make sure that the variables are independent. It's usually going to, address this and mention this in the problem, but make sure you understand this, because if the variables are not independent, that means that one of the variables occurring is going to change the chance the other variable occurs. And it is possible to do calculations in those situations, but in this course we're not going to get to that level. It's more advanced, and it's going to be something you're going to learn in a higher level statistics course. So again, when you have random variables and we say they're independent, that means one of the variables occurring doesn't tell you nothing about the occurrence of the other one. It doesn't help you figure out the probability or determine the probability of the other variable. So if x and y are independent, x occurring tells you nothing about the probability of y occurring, and vice versa. Now, variance. The variance of random variables x and y, if we have that t is their sum, if t is equal to x plus y, then the variance of t will be the sum of the variances of x and y. So the variance of t, remember, the variance is the standard deviation squared. The standard deviation squared of t is equal to the standard deviation squared of x plus the standard deviation of y squared. Remember, so sigma sub t squared equals sigma sub x squared plus sigma sub y squared. And in general, you can apply this to a variable if it's like again, if t equals x plus y plus z, and the standard deviation or the variance of t will be the variance of x plus the variance of y plus the variance of z, and so forth. Now, the difference of random variables, if let's say we have another variable d that's equal to x minus y, then the mean of the difference of d, or the expected value of d, will be equal to the mean of x minus the mean of y. And for the last one that we're going to apply in this chapter is the variance of the difference of random variables. So if we have, again, that random variables x and y, and we have another variable d that's equal to the difference of x and y, so d equals x minus y, then the variance of d is actually going to be the sum of their variances. So the variance of d equals the variance of x plus the variance of y. Now, this is going to kind of seem weird. It's like, well, why isn't it there differences? But trust me for now, and I'm going to explain as we go through a problem, because it's going to be a lot easier for you to understand. But let's go through a practice problem. That's always the best way to master this stuff. Okay, so here we got that we have a dealership that keeps track of sales and lease agreements made during each hour of the day. And X is the number of cars sold, and Y is the number of cars leased during the first hour of business on a random selected Friday. So based on the records, these are the probability distributions of X and Y. X cars sold 0, 1, 2, 3, and 4, or 0, 1, 2, 3, probability 0.3, 0.4, 0.2, 0.1. Cars leased 0, 1, and 2, probability 0.4, 0.5, 0.1. Now we're gonna define t to be the sum of x and y, so t equals x plus y, and we're gonna figure out these problems. So first we're gonna find and interpret the mean of t, then we're gonna compute the standard deviation of t, then we're gonna figure out part C, but let's first do part A before we get to that. All right, so if t equals the sum of x plus y, if t equals x plus y, then the mean of t, mu of t, mean of t is equals to the mean of x plus the mean of y. Again, that's just from our formula on the previous page, right here. And so we have that the mean of x is 1.1. The mean of y is 0.7. And so the mean of t will be 1.8. Now, what does that 1.8 mean in the context of this problem? Well, if t is the sum of the number of cars they sell and lease during the first hour of business on a randomly selected Friday, then the mean of t is 1.8, and that's saying that they sell or lease about 1.8 cars during the first hour of business on a randomly selected Friday. So let's write that out. This dealership sells or leases 1.8 cars during the first hour of business. And we selected Friday. All right. Part B. Let's find the standard deviation of t. So the standard deviation of t, so sigma of t. Just really messed up on that matrix. So I can do that. Sigma standard deviation of t. We're going to first need to find the variance of t and then take the square root. Remember, the standard deviation is the square root of the variance. So we take the square root of the variance of t. So let's go back to the previous page of the formula. We're given that the variance is just the sum of the variances of x and y. So all we have to do to find the variance of t is to add the variance of x and the variance of y. So let's first find what's underneath the square roots. The variance of t equals the variance of x plus the variance of y. Remember, the variance is the standard deviation squared. The standard deviation of x is 0.943, so we're gonna have 0.943 squared plus 0.64 squared. And we're gonna get about 1.298849. Take the square root of this. And so the standard deviation of t will be the square root of 1.28849. Which will be about 1.34, 1.14. Let me just write that. Actually, I don't like cutting it off too early. So it's 1.13967. All right, now let's look at part C. Here we have that the dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. We got to find the mean and standard deviation of the manager's total bonus. So let's start off by first finding a formula for B. So we're going to have B equals. Now let's just think logically. If you make $500 for each car sold, then you're going to make 500 times the number of cars sold, which is going to be 500x. So B would be 500x plus $300 times the number of cars leased. That's how much you get as a bonus for cars leased. Y is the number of cars leased, so we get 500x plus 300y as our equation for B. Now we need to find the mean and standard deviation of B. So the mean of B will be equal to 500 times the mean of X plus, kind of said that, that's fine. 500 times the mean of X plus 300 times the mean of Y. Because remember, this is just multiplying by constant and measures of center multiply by that same constant. Remember from the previous lessons. Go back to it. Here a constant is, B, or in this case, 300 and 500. Now, we just basically plug the values in for the mean of X and mean of Y, and we'll get that. Let's go ahead, let's first do that. Get the mean of B. $500 times 1.1 is 300 times 0.7. Like 760. So the main bonus the manager gets is $760. All right, now let's find the standard deviation of the manager's bonus. We want to find sigma sub B. So again, let's find first the variance of B, because then we just take the square root of the variance of B, standard deviation. And variance of B will be equal to, now this is going to be a little different, because B is equal to 500 times X plus 300 times Y. So going back to the formula, when the variance of T is equals to the sum of the variance of X and Y. But there's not, again, this is, not, we don't have like an explicit value this is being multiplied. It's just like 1 times the variance of X squared plus 1 times the variance of Y squared. Here we have, X being multiplied by 500, so and Y being multiplied by 300. So in a sense, this whole thing is not really like one variable. It's another variable. You can make another variable up. You can call it whatever W. W is 500X, and you call this like whatever Z. Z is 300Y. My point is that think of those as another variable because you're squaring that whole thing. So if this is like, again, like if you want to just imagine this, if that whole thing was another variable, let's say W, and this whole thing was another variable Z, you would square that whole W. So you have to square the 500 and the X. So this becomes 500 squared times the standard deviation of X squared plus 300 squared times the standard deviation of Y squared. The common mistake is to forget to square the 300 and 500. Because again, it's a little hard to wrap your head around this at first. But again, just think of the 500x being a totally different variable, and the 300y being another variable. So if you want to square, W and square Z, you have to make sure you square the 500 and the 300. And so working this out, you're gonna get that variance of B will be 500 squared times sigma squared times the standard deviation of x squared to 0.943 squared plus 300 squared times standard deviation of y, 0.64 squared. And I'm going to work it all on my calculator, so don't worry about the work. And you're going to get this. This all adds up to 25917 6.25, about 259,000. But remember, this is the variance. So to find the standard deviation, we take the square root of the variance. So the standard deviation of B will be the square root of 259,176.25. You get about 509.09. All right, so now let's look at the second part of this problem. One is not over yet. So using the same data for parts D through E, we're going to define that the difference D is equal to X minus Y. And again, we assume X and Y are independent. That allows us to apply the formulas on the previous page that I showed you. So we're going to first find and interpret the mean of the difference and compute the standard deviation of the difference. And then we're going to go to problem F. So let's see what's going on here. So the mean of D will just be equal to the mean of X minus the mean of Y. And that's given straight up in our formula right here. It's pretty kind of intuitive. So that'll be 1.1 minus 0.7 to be 0.4. Now think about what that means. 0.4. Now this will depend on what value is being subtracted from what value. Since we're subtracting the y from the x, we're subtracting the number of leases from the number of cars sold. So this means that there are about 0.4 cars. There are about 0.4 more cars sold than leased on average, because again, it's positive. So then we just basically say that in context. So this would be, very formal. So we say over many Fridays. Dealership sells about 0.4 cars more than it leases. So over many Fridays, the dealership sells about 0.4 more cars than it leases during the first hour of business on average. All right, part E. Let's find the standard deviation of the difference. So standard deviation of D, again, we find the variance first, because then we just take the square root of the variance. So the variance of D. Now, remember, this is going to be counterintuitive. The variance of the difference is going to be just the sum of the variances of X and Y. So it's the same as the variance of T, or the variance of the sum. So it doesn't matter that you're subtracting X from Y in this case. What you're going to do is add the standard deviation of X, standard deviation of Y. Or I mean, yeah, standard, or there. The variance of x is the variance of y. Really struggling with my sigmas. So the variance of x is the variance of y. And we just square root all that. So this is the exact same as we got on the previous page, because that's what we did to get the variance of t. We just added the variance of x and the variance of y. So the variance of d is the same thing. You don't have to worry about doing all that work. Go ahead and write that. Variance of d, then again be equal to the dot 1.13967. The same as the variance of t. Now, it says that now part F, the dealership manager received a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the difference in the manager's bonus for cars sold and leased. So in this part, we're gonna have to make up our own formula for the difference in the bonuses and the differences in the bonuses earned for cars sold and cars leased. So let's make a new variable. Let's make like lowercase d to uppercase d. This will be the difference in bonuses for cars sold and cars leased. And remember, we're doing x minus y. So we're gonna have 500x, 500 times x, minus 300 times y. So similar to the part before, or you found, uppercase b, except instead of adding them, I'm subtracting them to find the differences. 500, you get $500 for each car sold and $300 for each car leased. And so we want to find the mean of d, so mu sub d. That'll be similar to what we did in the previous part. That'll be 500 times the mean of x minus 300 times the mean of y. Don't worry that you're subtracting, because it's it's essentially the same principle of adding, because subtracting is just adding a negative number in a sense. But don't worry about you having to do something different. You just applying the same techniques. And so again, it's using this, we'll get the mean of d is 500. The mean of x is 1.1 minus 300 times the mean of y, which is 0.7. Gets 340. $4 for the mean difference in bonuses. So looks like he's making more money from bonuses in cars sold, because again, we're doing x minus y. And he's making on average, he's making $340 more in bonuses from cars sold than cars leased. All right, now the last part. Find the mean and standard deviation for the difference in the manager's bonus for cars sold and leased. Cars sold and leased. So if you want to find the standard deviation of d, you need to find the variance of d and then take the square root. It's like we've been doing for the other variances. So we find the variance of d. And again, this is going to be a little counterintuitive, but the variance of d is just going to be the sum of the variance of 500x and 300y. We're still, essentially applying this formula. The mean, or the variance of the difference is equal to the sum of the variances of x and y. Now, again, I won't spend too much time, going over it again, but it's the same principle as the previous part. We need to make sure that we square the 500 and square the standard deviation of x. So this will be 500 squared times the standard deviation of x squared plus 300 squared times the standard deviation of y squared. And then we just, now it's just algebra work. So then that'll be 500 times, again, the 0.943 squared over 500 squared plus 0.943 squared plus the 300 squared times 0.64 squared. And you're going to notice, yeah, well, what's going on? This is the exact same formula or exact same values as we're getting for the previous part where we found the standard deviation of the manager's total bonus. So we're going to end up getting that the standard deviation of the difference in the manager's bonuses for cars sold and cars leased is $509.09 again.